It's something we don't use very much. It doesn't tell you what amperage it is. You can start looking up on the websites and you can start looking at it. ESAB, Lincoln, Voestalpine, many of the filler metal manufacturers, and a lot of times you can find the general guidelines of where to start. And then at that point, you'll want to fine tune it yourself. Looking at it, you're never going to always have the exact amperage given to you. Everybody welds a little bit different. Some's natural ability or speed is different than everybody else's, okay? Good conductors require more heat than poor conductors. Page 343, left-hand column, I want you to go about 3/4 of the way down under the bolded item position of the weld. Welding in the flat and horizontal positions can be done with a higher current than welding in the vertical and overhead positions. We talked about this before, I have. If we're looking at that range, the lower end is usually reserved for the vertical position. Now on overhead, I prefer to weld up at the higher side again. It takes more energy to push something uphill. To push something overhead or to throw something over your head. When we're welding vertical, we're kind of just letting it lay in on top of the path that we have stacked for it, or the shelf, so to say. Okay. Size and the shape of the work. Naturally, if it's a thin piece of material, I'm gonna approach it so I don't blow a hole in it and create too much heat input. Control distortion, so forth. The type of joint, absolutely as well. Whether it's if it's an open rut with backing strip, 70-18. If it's open rut, no backing strip, it's going to be a 60-10 rut pass. We don't do 70-18 open ruts. You can. It can be done. It takes a severe amount of skill, and for most of the industry, it's not a common practice either. Okay. Position of the weld, that's what we just talked about. This one's important too, kind and condition equipment. No two machines can be set in exactly the same manner. And that goes true for our shop, every shop across the nation. Your machine, they're depending on the use and the wear, the windings within it may have a little bit more resistance, may have a little less. They could be two brand new machines out of the shop, or out of the box, just installed in the shop, and you may be 3-4 amps difference, okay? You may be able to do it just by slowing down, but if you set it up on a mechanized system, and you couldn't just say this is 100% preset. You'd need to fine tune everything individually, okay? So right here, the speed has the direct bearing on the current setting as well. A lot of times you match your speed to the current. Don't match your current to the speed, especially when we are the ones that need to be flexible. Our hand-eye coordination and skill. Okay? Electrode angle. I'm going to read from the book, page 343, right-hand column, halfway down under electrode angle. The angle of the electrode to the work affects the quality of the weld. The proper angle prevents undercut and slag inclusion and makes it easier to deposit the filler metal in the weld. Because it influences surface tension and the force of gravity on the molten metal, the correct angle promotes uniformity of fusion and weld contour in vertical and overhead welding. Especially these two right here are where you start to really see the rod angle be a big difference. So, for example, if I'm welding vertical, okay, if I'm trying to drag it uphill like this, what would you think if we had a water hose and we were welding, or we were bringing our water hose like this? It's just going to bounce off and come straight out, right? Well, welding material or welding metal is the exact same thing. It's a liquid. It does freeze faster, but if we're trying to weld like this, it's gonna roll out the bottom, and it's gonna give us a poor appearance. So we want to counteract it. We want to take, just like we were painting or anything else, and we would want to push our liquid this way. Just a slight angle, doesn't have to be drastic. Just about a 20-degree angle uphill, flat to a 20. I know some people like different things. Usually right in there is a good starting point, okay? And that way you're kind of letting that weld stack and go in there at the correct rate, solidify without kind of pouring or running out the back side, or the front side even as well, okay? Now we get to overhead. It's also the same thing. I especially want you to think about your garden hose in this case. If you take your garden hose and you put your water straight up and down like this, your water's going to go up and then come straight back down. Now naturally you want to try to drag it, especially in certain positions. If we were to drag it this way, our water would come up and go out this way, correct? It would create that arc. Well, your liquid metal is going to do the same thing. You're going to heat, you're going to throw your metal up here, and then it's going to start to droop here. As it's solidifying, it's drooping on the back side. So you want to make sure to keep, especially with 7018, it's really bad about it because it doesn't freeze. It's not a fast freeze rod. You want to make sure your 7018 stays straight up and down as much as you can. Okay? Now on a fillet weld you can get away with a little bit of a drag, but on a groove plate weld straight up and down directly above, you want to make sure that you're going almost 90 degrees perpendicular to the plate. If you start altering your angle this way or this way, you're going to starting to see weld metal build up and start to sag on the back side. Okay? So it says here, table 13-3, it gives you the welder's troubleshooter. This is a good point, but especially starting out, you want to come talk to us and make sure we've had years of experience of looking at welds, usually figuring out what's going on, and we can usually help punch you in the right direction a little bit quicker than this. Okay? Okay, right here, welding with shielded metal arc electrodes. So we're going to go to page 347 in the book, chapter 13, page 347, left-hand column, underneath the figure there in the table. I want you to look at, we're going to start out where shielded arc welding metal electrodes produce weld metal characteristics that are superior to the base metal. In this course, we will be concerned with those types of shielded arc welding metal electrodes that are widely used in industry and covered electrodes in the following AWS ASTM classifications. Move to the right-hand column of the same page. Second paragraph down, it starts out, you will observe fusion of the weld metal and base metal so that you will gain a good understanding of its action and importance. The arc requires that the welder hold an almost perfect arc gap for a weld of good appearance and quality. Practice will help you develop a steady hand and make it easier for you to make good welds. Okay, this is where I'm going to stop the lecture. There's a lot more. Well, let's run through the PowerPoints real quick. I want you to look through the PowerPoint and look through the book on your own. A lot of it from this point is going to show you different weld profiles, patterns, some prints, so forth. Okay. Welding technique. At this point, hopefully, I've showed you a couple different techniques that I think worked well. I've worked with a lot of students. I'm usually able to sit back and watch and see, kind of determine what they may or may not be seeing, and helping them move forward in their progression of skill set. So in this case right here, I don't necessarily think that the tapping technique is good. But what I use a lot of times is the wooden match method. It's kind of the same thing. It's you come right back to it, okay? Instead of just a short tap, it's kind of like a wooden match, strike it. As you get more and more comfortable, you get more and more, or as you get more and more practice, you get more and more comfortable starting, stopping the arc, and so forth, okay? So here's a typical blueprint, just showing some different skills. Start familiarizing yourself with blueprints, sizes, dimensions, how to read through them, and so forth. Now in this case, it's having you start some center line punches. You can also use some soapstone to help draw some lines for you as well, okay? For the inspection portion, especially at this point, come talk to us. You know, we're going to point some things out, help you understand to where you're starting to inspect your work as you're moving along, okay? It's very important. The welder is the first inspector, okay? Stop it as you're going. If you are welding along and all of a sudden something goes haywire, okay, and you don't understand what happened, don't continue welding. Stop right there. Come back in if you need to. You can grind it out and fix it. We need to start that habit right away. As soon as something starts going haywire or kind of acting goofy, we need to stop welding, fix the problem right there, then pick it up and continue on, creating a good, solid quality weld. Okay? Now refer to a job drawing. For most of what we're doing in the shop, you're going to see positions. We're going to give you a position, filler metal, and then a progression. And you're going to kind of decide from there where to go. Okay? So, I'm going to kind of zoom in here. You'll see this. But if you notice, right here, what's happening is exactly what we don't want to happen. Okay? You notice we're having welds here. I mean, they're just putting them side by side for now. That's all they're doing. However, if we want to stack those together, we don't want this big air gap or this void here in between. We want to make sure our weld comes off the top crown. So this weld needs to be overlapping this by half, so forth. Here's a good example of a weave bead. More than likely we've worked on it already with you, depending on where you're at in the program. Yeah, just kind of read through this, familiarize yourself. There's some things in here you'll pick up, for sure. It's good information. For the most part, it's good, solid information. Keep continuing on. So when it comes to actually doing the welds, we're going to follow the check-off sheet assigned to your course. Those will be the welds that you're doing. Again, we are teaching to the harder thing. So not necessarily starting out on an edge joint, but stacking beads. We're going to do fillet welds. If you can do a fillet weld, you can usually do an edge joint very well. Okay. By the time we get to 3-bead multi-pass fillet weld, if you can do that, then you can always come back and do an edge weld. More than likely, you're going to be able to do a corner weld, lap weld. A lap is still a fillet weld. Okay, or a lap joint is still a fillet weld. And so forth. We're going to teach to the harder weld to do, the harder skill set, and then the easier welds will come naturally. So here's a lap weld. Again, this is still a fillet weld, or a lap joint, but it's still a fillet weld. Okay? So, if you notice, it's a triangular shaped weld. It would be the same as if this piece were going straight up and down on a T-joint. Still a fillet weld. What we're mainly focusing on here, especially on the lap weld, is we want to make sure that we push that weld puddle up to this direction. Now I wanted to stop in this slide specifically because I don't agree with it. And most of you have seen at this point, especially this is a horizontal position, we're defying gravity. I would say that this 45-degree angle needs to be turned down more to about a 20. So I'm going to help push that liquid up there. If you stay at the 45, you're going to be heavy on the bottom and light on the top, quite possibly creating some undercut up here. But if you drop it down to a 20, again, your funnel is going from here. You're kind of going to push it up in there. You're not going to shoot over top of it, trust me. And you're going to help push that profile up to where it's nice and even, so we're looking for an equal leg weld. Okay, so when we measure a fillet weld, we measure the toes. We measure how the distance from here to here and here to here. Okay? We're still maintaining our 15 to 30 degrees this direction, but we're going to drop from 45 down to about a 20. Now your second pass, you're going to turn up, and then if it was a multi-pass fillet weld, in this case it's only going to be one pass, but on a T-joint it would be it would be 3 beads, second bead would be here, third bead here. Very important in horizontal and overhead that we stack our welds like we would build a home. We would not set the roof first, we set the foundation first, we go from the bottom to the top. Okay? This is your horizontal one. I think this one's great. It shows you a little bit of an upward angle. Okay? Still a little bit of a drag angle as far as the side manipulation. Now notice in this pattern, it shows the beads overlapping. Okay? That's what we're looking for in this blueprint. Okay, I'm going to stop there. You can continue reading through the PowerPoint. Let's talk a little bit about how we size and judge welds, okay? One thing that would be a good practice to start doing at this point is to start shooting for a common, I guess, to get uniform and comfortable with kind of weld sizing as you're welding and getting used to the measurement of how we measure welds. So, as we're going along, first couple courses, it will be specific to T-weld joints. Okay? So, what we will be doing should have taken blueprint reading at this point, so you've more than likely been through it. However, never hurts to know to brush up on it again, okay? So when we're producing a fillet weld, we measure a weld by the shortest and smallest dimension within that weld. So in this case, we're looking at our leg size, okay, in a fillet weld. So our leg is from the root to the toe of the weld. So say that's 1/4 inch, and this is 1/4 inch. Now what happens if we have this? Oh, now we have an unequal leg size. So this might be 1/2 inch, and this height is still at 1/4 inch, okay? Now if it was specified that it had to be a 1/4 inch weld, this would be too wide. This would be a bad rejectable weld, okay? Sometimes we may specify for a 1/2 by 1/2 inch weld, but we can't do that in one pass, not with a 60 or a 70/18 1/8 inch electrode. So we may have to do a multi-pass weld. So we want to put the first one in, and then we're going to put the second one in, and then we're going to put the third weld in. So, again, this isn't to scale, okay? The way we measure this weld is the largest isosceles triangle that will fit within that fillet weld. So I will draw it a little larger. Say we have the multi-pass weld, and here's the side of our weld profile. So we have to make sure that our isosceles right triangle can fit within this weld. So it cannot come all the way out here, because that's not correct, okay? We have to make sure that it goes right there. So according to this, even though our toe is way out here, the largest isosceles triangle to fit within that weld profile is right here in the center. So our weld would be measured from here to here. Now if we have a nice smooth transition with a slightly convex weld pattern, then our weld is going to be from toe to toe. Let's go the reverse. Okay? What if we do not have a convex weld pattern? What if we have a concave? Okay? Now, our weld, our toe, I should say this is out here at 3/4 of an inch. However, our largest isosceles triangle that will fit within that might only be here at, say, 1/2 inch. So this is then a 1/2 inch weld. And if it was specified or spec'd for a 3/4 inch weld, this is a rejectable weld. In this case, you're able to fill it a lot of times, okay? However, when it's the opposite direction, then you have to cut some out or grind it off, which is not always acceptable in the real world, okay? We get into groove plate welding. I'll explain more of that, how we size groove plates and so forth. All right, thank you, and please come see me if you have any further questions.